Yeah, welcome to YourPedia. Welcome to YourPedia. So we are going to solve PYQs and some good questions which are at the level of HPCL officer examination, and I can say equally applicable for JO also. Little bit level is high for JO. These questions JO, but for officer level perfectly PYQs. See, these are PYQs, and along with some good questions, in which our topics will be revised. Right? हम शुरू कर रहे हैं HPCL जई ऑफिसर का PYQs, ये HPCL का ऑफिसर का PYQs है, और उसके बाद HPCL कुछ क्वेश्चंस प्रैक्टिस क्वेश्चंस भी इसमें कर रहे हैं हम. सो मोर देन 50 क्वेश्चंस हम सॉल्व कर रहे हैं. मोर देन 50 क्वेश्चंस हम सॉल्व करेंगे इसमें. देखिए फर्स्ट क्वेश्चन क्या है. Which of the following statement is correct? Which of the following statement is correct? First statement: transient response of an electric circuit can be best be described by a linear differential equation. Yes. So you see this kind of questions where students will lose marks. Okay, students are able to do any I can say numerical question, but you see uh, there are some terms, कुछ terms उसने यहाँ पे use किया है. क्या है? Linear differential equation. Linear differential equation, right? Yes, the equations of, I repeat, the equations of any RL or RC or RLC, series or parallel, whatever it is, any dynamic system are linear differential equations. The equations of any I can say any physical memory system, means which is having inductance and capacitance, or dynamic system, that is called as dynamic system, are what I can say linear differential equation. Yes, this statement 1 is perfectly correct. Okay, a dynamic system or a system which is having memory means inductor and capacitor, energy storage, or the system containing energy storage elements is represented with help of linear differential equations. Right? Next, Laplace transformation is very powerful method of solving linear differential equations. Yes, that is also, second statement is also very much correct. We are using Laplace transformation. I repeat, we are using Laplace transformation for solving linear differential equations. That is a powerful tool. In fact, without Laplace transformation, solving linear differential equations is difficult. Yeah, we have a normal method also to solve differential equation. What is that normal method? Complementary function and particular integral. Total response is equal to complementary function plus particular integral. So that way we will solve. But that is a lengthy process, and it is a difficult process. It is not suitable for all given questions. But this Laplace transform method, solving a question by using Laplace transform of a transient network, which contains which is written in terms of linear differential equations, is possible with help of Laplace transform only. So both statement 1 and 2 both are correct. Option 3 is perfectly suitable. Right? Let's go to the next question. Which of the following is correct regarding Laplace transform? Okay, some points he given related to Laplace transform. What is saying? First one, Laplace transformation also provides direct solution for non-homogeneous differential equations. Yes, it is going to provide direct solution, right? Direct solution. This method automatically take care of initial conditions without the necessity of determining the general solution and then applying the particular solution. Yes, see, there is advantage of Laplace transform. If you are going with the normal solution of a differential equation, I repeat, if you are going with the normal solution of a differential equation, you have to, if you are going with the normal solution of a differential equation, you have to find the complementary function and particular integral separately. But with the Laplace transform, directly you will get the total solution, right? Both 1 and 2 are correct. Statement 1 and 2 both are correct, right? For JU level, those questions are not there. Those concepts are not there. Okay, next. In frequency domain network having n principal nodes, and one of them is designated as a reference node, and we require dash node voltage equation to solve for the desired result. See, number of nodal equations required. Number of nodal equations required is equal to number of nodal equations required is equal to total number of nodes minus 1. Total number of nodes minus 1. It may be frequency domain or time domain, whatever it is. चाहे वो frequency domain हो या time domain हो, that is from frequency domain or time domain, the number of equations required to solve a particular network with help of nodal analysis is equal to n minus 1. N minus 1. Option is 4. Option is 4. Right? Option is 4. N minus 1. See, people may get abstracted here by looking at the term frequency domain. By looking at the term frequency domain. Right? Frequency domain. वो टर्म देखने के बाद सर फ्रीक्वेंसी डोमेन में हमको नहीं पता, टाइम डोमेन में तो n-1 है, तो आंसर इज n-1 only. Domain is not going to change the number of equations for the same method. I'm talking about domain will change, I can say, differential equations into algebraic equations. Time domain is going to have differential equations. Those differential equations will become algebraic equations in frequency domain. That's all. But it is not going to change. It is not going to change number of equations. Please do remember that point. Next, if the resistance in delta connected resistive network is R1, R2, R3 as shown in the figure, R1, R2, R3, then what will be the value of Rx in the equivalent star network? So this is Rx, may not be visible to you clear. Rx, this is Ry, this is Rz. Very simply, he is asking us to convert from delta to star. He is asking us to convert from delta to star. Yes, Rx is equal to product of the connected elements. This is R1, this is R2, this is R3. I will tell you how to convert from delta to star. Product of the connected elements R1 into R3 divided by R1 plus R2 plus R3. R1 plus R2 plus R3. Right? R1, R3. Yes. If I want Ry, which is connected between R1 and R2, Ry is equal to R1 into R2 divided by R1 plus R2 plus R3. Next, Rz, yes, that is here. Rz, that is here. Yes, Rz is equal to R2, R3 divided by R1 plus R2 plus R3. R1 plus R2 plus R3. Right? Next, the Laplace transform of a function f of t. See, Laplace transform of any function. See, if you have a signal in time domain, if you apply Laplace transform, integration of f of t multiplied with e power minus st with respect to time dt will give you the Laplace transform version. Yes, limits we have to take from minus infinity plus infinity. So then it is called as bilateral Laplace transform. Bilateral, yes. Bilateral, then it is called as bilateral Laplace transform. See, is there in the options? No. Then if that is, suppose if it is there in the option, this is our answer. You have to take the limits from minus infinity to plus infinity. You have to take limits from minus infinity to plus infinity. If that is not present, then we find a unilateral Laplace transform. Agar wo nahi hai, so integral 0 to infinity f of t into e power minus st dt. So this is called as unilateral. Yes, unilateral Laplace transform. Unilateral Laplace transform. Option 2 is perfectly correct. Option 2 is perfectly correct. Right? Option 2 is perfectly correct. Yes or not? Yes. Yes, let's go to the next question. Laplace transform of exponential function is described by. See, here options are not properly suitable. So actually, but see, the question is not framed well. Let's understand. Laplace transform of any signal f of s, just now we wrote that is equal to integral minus infinity to plus infinity f of t into e power minus st dt. F of t into e power minus st dt. We use this e power minus st as kernel. This is called as kernel. This is called as kernel. This is called as what? Kernel. Right? So s is not there. Instead of s, taken alpha. So e power minus alpha t. So this cannot be used. Or see, I'll tell you, question is not framed properly. 1 by e power alpha t can be written as e power minus alpha t. Right? 1 by e power alpha t can be written as e power minus alpha t. But See, question is not framed well. This question, see, for this question, everyone should get a mark. For this question, everyone should get a mark, right? For this question, everyone should get a mark, right? Yes or not? So, right. Come here. Which of the following is stated as final value theorem? See, final value theorem, final value if we want, final value. Final value of any function, final value of any function is equal to, take the function, apply, limit, t tends to infinity. Bus, that's all. Sir, ये time domain में है. Then how to get in frequency domain? See, time and frequency both are reciprocal to each other. Okay, time and frequency both are reciprocal to each other. If time is tending towards 0, then s will tend towards infinity. If time is tending towards infinity, then s will tend towards 0. So final value is equal to limit, in place of t, s 0, f of s into f of s, s into f of s. Final value is s into f of s. One s will come extra in the s domain. Observe it here, please. Observe it here. One s will come extra. One s will come extra here, right? Yes or not? Yes. Next. Which of the following statement is correct about capacitors? He is asking which of the following statement is correct about capacitors. Let me increase the size. Let me increase the size of the question so that it is visible for you properly. Right? What he's saying. The capacitor, sometimes referred as condenser. Yes, capacitor is referred as condenser. Is a simple passive device that is used to store electricity. Yes. Yes, that is perfectly correct. That is perfectly correct. Statement 1 is perfectly correct. Due to insulating layer, DC current cannot flow through the capacitor as it blocks it, allowing instead of a voltage to be present across the plates in the form of electric charge. Yes, capacitor blocks DC. Capacitor, yes, blocks DC. It allows AC, but capacitor blocks DC because of that insulating material which is going to block the DC, right? So both 1 and 2 are correct. Both 1 and 2 are correct, right? Next. Next. Right. Come here. Next. The mesh current analysis. The mesh current analysis technique is applied for all networks with independent sources or networks with dependent sources. I repeat the statement. The mesh current analysis technique is applied for all networks with independent sources or networks with dependent sources where the controlling variables are not part of the network under investigation. Yes, perfect. See, statement दिखने में big दिखता है. Independent sources हो या dependent sources हो, mesh analysis is perfectly applicable. Independent sources हो या dependent sources हो, circuit में mesh analysis is perfectly applicable, right? Next, if the controlling variable is part of the network being examined, additional care must be taken when applying the mesh current analysis. Yes, yes, that is also perfectly correct. Both 1 and 2 are correct. See, HPCL exam में जितने भी ऐसा statements 1-2 statements दिए, ये पेपर में ही गिवन ऑल आर बोथ 1 and 2 आर करेक्ट. लेकिन आप लोग ये वाला ट्रैप में नहीं रहना कि don't be in this trap by saying like okay any question both 1 and 2 are correct, any question both 1 and 2 are correct. No, that is not correct. That is not correct. But ये वाला पेपर में जितने भी स्टेटमेंट 1 and 2 दिए हैं both 1 and 2 are correct, ऐसा दिया है उसने क्वेश्चंस. ठीक है. Next question. Which of the following statement is correct? A node is a junction of 2 or more branches of an electrical network. Yes, see, a node is a point at which more than one branch meets. This is a node. Yes, more than one branch is going to meet. More than one branch is going to meet. Perfect. Next, KCL also indicates the law of conservation of charges and can also be stated as any node of a circuit at every instant of time, the sum of incoming currents is equal to sum of the outgoing currents. Yes, what KCL says, suppose this is IA, IB, this is IC, ID is outgoing, sum of the incoming currents. Yes, IA plus IB plus IC is equal to ID. IA plus IB plus IC is equal to ID, right? Both 1 and 2 are correct. Both 1 and 2 are correct, right? Both 1 and 2 are correct. Next, Which of the following equation is stated as initial value theorem? See, previously we saw final value theorem. Now initial value theorem. In time domain, what it is? Limit t tends to 0, f of t will be initial value in time domain. This is in time domain. In frequency domain, in initial value is equal to limit s tends to infinity. Time t tends to 0 means s tends to infinity. F of t will become f of s, but one s will come extra here, s into f of s. S into f of s, right? S tends to infinity, please. So it is looking like 0, 0, 0, 0. It is not 0, 0. It is infinity. It is infinity. Option 2 is perfectly correct. Option 2 is perfectly correct, right? Next up. In the given circuit diagram, determine the number of junction points and meshes. Junction points means nodes. Junction points means nodes. Yes, meshes. What is a mesh? Mesh is a closed path. Mesh is a closed path. It is a closed path in which no further closed path. In which no further closed path. No further closed path. Mesh is a closed path in which no further closed path exists. No further closed path exists. ये एक closed path है, ये दूसरा है, ये तीसरा है. 3 meshes है. Meshes are 3. Number of meshes m is equal to 3. Nodes कितना है count करेंगे. Yes, let's count the number of nodes. See, this is a node. Here something we are going to learn. What is the difference between a normal node and a principal node? What is the difference between a normal node and principal node? We will learn here. Yes, what is the difference between a normal node and principal node? We are going to learn here. That is node 1. This is node 2. This is node 3. This is node 4. This is node 5. This is node 6. Node 7. Node 8. All these are. This is the combination of simple nodes and principal nodes. I repeat, combination of simple nodes and principal nodes. Simple nodes and principal nodes. लेकिन इसमें ऐसा कोई ऑप्शन ही नहीं है. Yes, one. See, this is a simple node. Why simple node? Why simple node? There is no current division. What is the difference between simple node and principal node? If there is a current division at 2 points, then it is called as at a point it is called as a principal node. No current division, simple node. This is a principal node, NP2. Okay, this is simple node, NS3. This is principal node, NP4. This is principal node, NP5. This is simple node, NP6. This is principal node, this is NS6. This is simple node, please. 6 is NS6. This is NP7. This is NS8. But 8 is not there in the options. Then he is asking about principal nodes. 1, 2, 3, 4, 5 principal nodes are there. But 5 is also not there in the options. Yes. This is a principal node. Yes. This is also a principal node. Yes. This is also a principal node. Sorry, this is simple node. Sorry, I mistaken. I marked. This is simple node, please. Let us count again. We counted properly, but last counting we did the wrong way. This is a principal node 1 plus. This is a principal node. Yes, 1 plus. This is a principal node 1 plus. This is another principal node 1. Total how many? 1, 2, 3, 4. There are 4 principal nodes. Yes, 4, 3. 4, 3. Right? 4, 3. Yes or not? Yes. Next, find R equivalent in the given circuit. Find the R equivalent in the given circuit. See, yes, he is saying R equivalent from here. Nothing. Just you go and stand there. Make the series and parallel combinations. Yes, sir. These two are in series. 52 plus 28. 50, 20, 70, 80. This is 80 ohms. 80 ohms in parallel with 20. 80 in parallel with 20 is equal to 80 into 20 by 100. 0, 0, 0, 0 gone. 16 ohms. This total is 16. Here it is 16. Now R equivalent is equal to 15 plus 25 plus 16. 15 plus 25 is 40. 40 plus 16 is 56 ohms. Yes, it is 56 ohms. It is how much? 56 ohms. Right? Next, it is how much? 56 ohms. Clear? Yes. Find current I in the given circuit. Find current I in the given circuit. I is equal to 12 divided by 100 plus 300 plus 400. That's all. Series circuit. Na? All are in series. 100, 200, 100, 300, 400, all are in series. 12 divided by 500, 600. 12 divided by 600, 2 cities, 2 divided by 100, that is equal to 0.02 amperes. 0.02 amperes. No, where we committed mistake? In the calculation? In the calculation we committed mistake. 700, 800, sorry. This is 800. Yes, it is 800. 3 plus 4, 7. 7 plus 1, 800. This is 800. Okay, just a minute. Then 2 4s, 2 2s. Yes, it is 0. Yes, 0.15 ampere. Simplification. Just you can do that simplification. Option is A. Just I wrote wrong value there. I wrote wrong value. Right. Next. For a series RLC resonant circuit with two half power frequencies 36 and 25 respectively, find the resonant frequency. Find the resonant frequency. This is a direct formula based question. Direct formula based question. Yes, that resonant frequency easily we can get. Yes, I'm giving you 1 minute of time. All of you solve it, please. Solve it and give me the answer in the chat box. It is a direct formula based question. Yes, two half power frequencies. Yes, I am giving you 1 minute of time. See, if you have any question, you can type in the chat box. Okay. 1 minute is the time I'm giving. Yes, 1 minute is the time I'm giving. Only simple formula, simple formula. See, if you know that simple formula, answer is done. If you know that simple formula, answer is done. Yes, so none of you answered. Yes, I'm doing it. So half power frequencies, resonant frequency is equal to square root of half power frequencies. This is a lower cutoff frequency, this is upper cutoff frequency. So f naught is equal to under root of 36 into 25. Do this, you get the answer as 30 kilohertz. Both are in kilohertz. Both are in kilohertz, please. 36 and 25, both are in kilohertz. Next question. Find the voltage at node B in the given circuit. He is asking voltage at node B. This is a direct question. If you want voltage at any point, from that point you go to the ground. You go to the ground. See, do one thing. B is there. B is there. Yes. Minus plus. How much is this? 12 volts. This is the ground. This is point B. Now he's asking voltage of this one. Do one thing. Let's take this voltage as VB. Write the KVL for this one. We are assuming this voltage as see, he is asking with respect to B. He mean to say that B is at positive. We assume like that. B is at positive, right? Write the KVL. Minus VB minus 12 is equal to 0. So VB is equal to minus 12 volts. VB is equal to how much? Minus 12 volts. So whenever you want to find voltage at any point, you write the KVL. Sir, how to write the KVL? Wherever you want to see, in what way you want to write, in that way you can write the KVL. But you must get less number of unknowns in that, so that the process is easy for us, right? That is a simple and direct question. Simple and direct question. Okay. Next, find the current IM in the given circuit. He is asking about this current IM. Now, this is downside to the downside 5 amperes. To the downside 5 amperes. Now, this is 5. Apply current division. How much is the current going this way? Let's name it as Ix. We know that Im is equal to minus of Ix. Yeah, he's asking current in this direction, but we are finding in this direction. Why? Because current is coming this way. Ix formula is what? Current division 5 into opposite resistance by total resistance 50. 5 densities, 10 densities, 1 gone. So Im is equal to minus 1 ampere. Im is equal to what? Minus 1 ampere. Option is 2. Minus 1 ampere. Option is 2. Yes or not? Yes. Next. Find the current I in the given figure. Again, he's asking us to find this current I. This current I. So very simple. These two are in series. First of all, how much it is? This total is 750. 750 is in parallel with 500. See, this total is 750. That is in parallel with 500. So 500 into 750 divided by 500 plus 750. How much it is? 1250. Yeah. Yes. 200 will be left, 1250, 1250, 0 gone. 525s, 5, or let's take 25 5s, 25 3s, 5, it is hundreds. So it is 300 ohms. This is 300 ohms. 300. See, this total is 300. 300 plus 200. Total is 500 ohms. Right? Total is 500 ohms. Means 40 volts is experiencing 500 ohms. Yes, observe it carefully. 40 volt source, I repeat, 40 volt source is experiencing, 40 volts source is experiencing, yes, how much it is experiencing? It is experiencing 500 ohms. Now the current, total current ITL, right? Current IT is equal to 40 divided by 500. 0 gone. Yes, 4 divided by 50. Yes, 4, yeah, 2 2s, okay, 225s, 2 1s, 2 12s, 1 divided by 12 ampere. 1 divided by 12 ampere. This total current IT is equal to 1 divided by 12 amperes. Now this I is equal, apply current division, 1 by 12 into, this current is 1 by 12 into, opposite is 500 divided by 500 plus this 750 is 1250. 1250. Yes, how much we got this one? Yeah, otherwise we'll do it again. 500s, 5 250s, 250s. Again 520s, 5 50s. Yes, 0 gone. 2 by 5. So 1 by 12 into 2 by 5. 2 6 it is 1 by 30. 1 by 30. So 1 by 3 is 0.33. So 0.033 amperes. 0.033 amperes. So this can be written as 33 milliamperes. 33 milliamperes. This can be written as 33 milliamperes. Option is 3. Option is what? 3. Option is 3, right? Next. Supernode is considered when there is a dash between two nodes. Supernode is considered if there is a dash between two nodes. Observe. See, suppose there is a resistance here, a node here, a voltage source is here, and there is a node here. Here, this way it is there. I can't write the KCL here. I can write, but if I know this current, but I can't apply Ohm's law here. Means whenever there is a node, there is a voltage source between two nodes. Whenever there is a voltage source between two nodes, supernode is considered. Whenever there is a voltage source between two nodes, supernode is considered. Whenever there is a current source between two loops, supermesh is considered. See, whenever there is a voltage source between two nodes, yes, supernode is considered. Supernode is considered, comma, whenever there is a current source, between two loops, two meshes, then supermesh is considered. Option is 2, voltage source. Option is 2, voltage source. Find Vm in the given circuit. Apply voltage division. Vm is equal to 8 into, yes, 25 divided by 25 plus 75. So 8 into 25 divided by 100. 25 4 cities, 4 2 cities. It is 2 volts. Option is what? 2 volts. Right? Option is 2 volts. Next question. In a series RLC resonance circuit, at resonance, the current drawn by the circuit is maximum. In series resonance, the current drawn by the circuit is maximum. Yes. Yeah, if you draw the current, this is frequency, this is resonant frequency, this is frequency, this is resonant frequency, this is, sorry, I went with wrong color, white color, yeah, resonant frequency. So this is how current will be. This is the maximum current. This is current I of t. How impedance will be, not voltage, how impedance will be. The impedance is minimum. Yes, impedance is minimum, right? So here XL is greater than XC, or sorry, XC is greater than XL. This is XL is greater than XC. Here at resonance, exactly, the resonance is the point at which XC magnitude is exactly equal to XL magnitude. That is called as series resonance, right? Yes or not? Yes. Next question. If a circuit load impedance is 25 minus J25, find the power factor. He's asking about power factor. Cos phi is the power factor, which is equal to R resistance by magnitude of the Z, or that is equal to P by magnitude of S. Both are correct. But here he did not given P and S or Q. Therefore, this we are not going to use. This is correct only, but not useful as of now. वो यूज नहीं होता क्यों क्यों यूज नहीं होता he is asking he given what is the given data as per the given data it is not yes as per the given data it is not useful. So power factor is equal to cos phi is equal to resistance is how much 25 mod z root of r square 25 square plus 25 square. So 25 divided by 25 you take common, you are left with root 2. 25 divided by 25 is 1 by root 2, that is equal to 0.707. The power factor nature is lead nature. The reason is the power factor nature is lead in nature. The reason is this impedance is R minus JX. Okay, negative impedance, negative reactance means reactance is not negative, but in the impedance you find that as minus. In the impedance you find that as minus, right? Next, yeah, just a minute. Hold for a minute. There are some white pages. Just a minute, please. Hold for a minute, please. Hold for a minute. We'll resume. Yeah, it's fine. Yeah, there was some technical issue. See, we are going to solve some, I can say, important questions through which we are going to learn concepts of networks for HPCL officer examination. We solved previous questions of HPCL officer. Then these are the important questions, okay, of the same kind, Okay, let us start. Let's start. Yes. Which of the following laws states that in any electrical network, the algebraic sum of currents meeting at a point is zero? KCL. What KCL says? Sum of all the incoming currents is equal to sum of all the outgoing currents. I repeat, KCL says sum of all the incoming currents is equal to sum of all the outgoing currents. Right? Kirchhoff's current law, KCL. KCL says that rule stating that yes, sum of all the incoming currents is equal to sum of all the outgoing currents. That is simple question, right? This is not only for currents, it is applicable for charges also. Why? Because charge is current is equal to what? I is equal to dq by dt. I is equal to dq by dt. It is equal applicable for charge also. Okay, so which of the following last in any electrical network the algebraic sum of currents or charges? Yes, here sometimes he may give the question as charges, sum of all the currents or charges. It is applicable for charges also, right? Next step. The resistance of a conductor is directly proportional to, you see, simple question, R is equal to rho L by A. Resistance is directly proportional to length, inversely proportional to area. Inversely proportional to area. It is directly proportional to length. You may be thinking, sir, why you taken this much simple questions? Yes, we solved some previous year questions now. Those previous year questions are also of the same range. Those previous year questions are also of the same range, right? Same range. Next, the resistance of 1 farad capacitance, the reactance of 1 farad capacitance when connected to a DC circuit is, see, if you connect to a capacitor to the DC, first of all, what is the reactance formula? XC is equal to 1 by 2 pi FC, 1 by 2 pi into F is what? 0 into C. The reactance is infinity. The reactance is what? Infinity, right? The reactance is infinity. For DC, see, you know, one question in the previous papers given, capacitor blocks DC, whether the statement is correct or not. Yes, statement is correct. Why? Because for DC, capacitance is going to behave like open circuit. For DC, capacitance is going to behave like open circuit. XC is equal to 1 by 2 pi FC, F is equal to 0. So XC is infinity. It is going to behave like open circuit. Option is A. Option is A, right? Yes. Now, next, a 10 ohm resistor connected in parallel. Yes, a 10 ohm resistor connected in parallel with a 15 ohm resistor. Okay, the combination is in series with 12 ohm. See, a 10 ohm resistance, this is 10 ohm, is connected in parallel with 15 ohm. Yes, that is that combination is in series with 12 ohm. That combination is in series with 12 ohm, right? The equivalent resistance of the circuit is, the equivalent resistance of the circuit is R equivalent. Now what is R equivalent? So R equivalent is equal to 10 in parallel with 15 plus 12, that is 10 into 15 divided by 25 plus 12. So 5 5s, 5 3s, 5 2s, 2 3s are 6, 6 plus 12 is 18 ohms. Answer is what? 18 ohms. Straightforward question, simple question, but instead of giving the circuit, he given theory with which you have to make the circuit. Instead of giving circuit, he given theory with which you have to make the circuit, right? Yes or not? Yes. See, questions of the same kind, what it is given in your HPCL previous officer paper, the same kind of questions we are taking here. Same kind of questions we are taking here, right? Two resistors, R1 is equal to 10 ohm, R2 is equal to 20 ohm, are connected in series in our series order to 30 volts direct DC current. Okay, find the ratio of P1 and P1 by P2 of the power expended or power absorbed by the resistors. C is saying 30 volts. Yes, this is 30 volts. It may be any volt V. See, sometimes voltage is not given. He mentioned it as V. So this is R1, this is R2, this is 10 ohm, this is 20 ohm. As both are connected in series, the current is same. Current is same through both the resistances. Yes, current is same through both the resistances. Now, P1 is equal to I square into R1 is 10. P2 is equal to I square into R2 is 20. Now, P1 by P2 is asking. need not to find, don't apply V by R, find the current, not required, not required. Directly I square gone, so P1 by P2 is equal to 1 by 2, very simply. So P1 is equal to half of P2. P1 is half of P2. So P1 by P2 is equal to 1 by 2. P1 by P2 is equal to 1 by 2, right? Next question, yes, the time constant. This question number of times it was repeated in your HPCL, both officer and JO paper. Number of times the question was repeated. Time constant of any RC network, it may be any RC, series RC or parallel RC or whatever it is, that is equal to R equivalent into C equivalent. The units are seconds. It may be any RC. So option is A. Option is what? A. Yes or not? Yes. Next, when the switch S is closed in given figure, then the current's value at a time t is equal to 0. If you close the switch at a t is equal to 0, yes, if you close the switch at t is equal to 0, so this is 200 ohms. Yes, capacitor is going to behave like a short circuit. Yes, now I'll give you one point here. This is a switch which is closed. Capacitor, see, here time, here element, capacitance, inductance, time t is equal to 0. See, I'll take this way, just a minute. Time t is equal to 0, time t is equal to infinity. T is equal to 0 means initially, t is equal to infinity means finally. Capacitor, then inductor, then inductor. Initially capacitor behaves as short circuit. Initially means at t is equal to 0. Yes, I repeat, initially means at t is equal to 0, capacitor behaves as short circuit. Yes, capacitor behaves as short circuit, right? Finally, at t is finally means at t is equal to infinity. Finally means at t is equal to infinity, capacitor behaves as open circuit. This behaves as open circuit. Initially, inductor behaves as open circuit. Finally, it is going to behave like a short circuit. It is going to behave like what? Short circuit. Now, he is asking what is the current. He is asking for the current I of 0 plus. So I of 0 plus is equal to 12 divided by 200 to 6. It is 6 divided by 100. That is 0.06. Answer is 0.006 means 60 milliamperes. So 6 milliamperes, but it is 60 milliamperes. The answer is what? 60 milliamperes. Option is C for Chennai. 60 milliamperes. Right? Next. A quantity whose magnitude has a definite repeating time cycle is called as, see, something which is having a definite repeating cycle is called as, see, I'll tell you, I'll tell you, see, this is a definite repeating quantity. This is a definite repeating quantity, right? Or yes, this is a definite repeating quantity. Then steady state periodic, transient state periodic, steady state aperiodic. This is steady state periodic. Yes, periodic, definite. See, definite repeating time cycle. Why it is not transient, sir? Transient transient is not repetitive. First of all, it occurs only whenever there is a sudden change of energy taking place in the system. Transient, first of all, transient state never be periodic. This is and it is a periodic. Why? Repeating cycle means periodic. It is not aperiodic. Therefore, option is A. Option is A for apple. Right? Next. And in the circuit shown in the figure below, if Is is equal to U of t, yes, Is is equal to U of t, that is fine. What are the initial and steady state voltages across the capacitor? Just now we discussed U of t means DC. U of t means DC. That is DC starts at t is equal to 0. DC starts at t is equal to 0, right? For at t is equal to 0 plus means initially, at t is equal to 0 plus means initially. So this is the resistance. This capacitance is going to behave like a short circuit. Capacitance is going to behave like what? Short circuit, right? अंकित शर्मा सर, डिप्लोमा के बाद फिर से एक बार थ्योरी पढ़ना होगा कि डायरेक्ट ऑब्जेक्टिव क्वेश्चन? सी, वो डिपेंड करेगा आपके पास नॉलेज कितना है. अगर आपका थ्योरी में नॉलेज बहुत अच्छा है तो डायरेक्ट ऑब्जेक्टिव क्वेश्चन में चले जाओ. मैं ये बोल सकता हूँ कि HPCL जैसे कॉम्पिटिटिव एग्जाम के लिए ज्यादा थ्योरी पढ़ने की जरूरत नहीं है. ज़्यादा थ्योरी पढ़ने की ज़रूरत नहीं है। डायरेक्टली आप ऑब्जेक्टिव क्वेश्चंस, जितना ज़्यादा ऑब्जेक्टिव क्वेश्चंस आप सॉल्व कर सकते हो उतना अच्छा होगा। जितना ज़्यादा ऑब्जेक्टिव क्वेश्चंस आप सॉल्व करते हो उतना अच्छा होगा, ठीक है? ये t इज इक्वल टू 0 पे शॉर्ट सर्क्यूट है तो पूरा करंट इसमें जाएगा ना, पूरा करंट इसमें जाएगा। नहीं, वो वोल्टेज के बारे में पूछ रहा है। तो शॉर्ट सर्क्यूट का मतलब क्या है? वोल्टेज इज इक्वल टू 0, वोल्टेज इज इक्वल टू 0 वोल्ट्स। तो इनिशियली वोल्टेज तो 0 है, फाइनली कैपेसिटर ओपन सर्किट होगा या इन स्टडी स्टेट, और फाइनली कैपेसिटर इज ओपन सर्किट। तो यहाँ पे वोल्टेज चाहिए, हम इसको V ले लें, और दिस करंट मैग्नीट्यूड कितना 1 एम्पियर है, क्योंकि u ऑफ t का मतलब क्या है? u ऑफ t मींस 1 फॉर ऑल t ग्रेटर देन 0 इक्वल टू 0 फॉर ऑल t लेस देन 0, राइट? So this is 1 ohm, that 1 ampere is flowing this way, so this is plus minus 1 volt. Yes, minus V plus 1 is equal to 0, therefore V is equal to 1 volt. Initially 0 है, finally 1 volt है, 0, 1 volt respectively. Option is C, option C है। सर आप अपने क्लास का प्लेलिस्ट बनवा दीजिए प्लीज। सो प्लेलिस्ट यू कैन फाइंड इन द यूट्यूब, आप यूट्यूब में फाइंड आउट कर सकते हैं जो भी क्लासेस अभी तक हुए हैं, ठीक है? What is the resistance of coil whose time constant is 2? वो बोल रहा है coil मतलब क्या? coil का मतलब क्या है? coil means inductance, coil means inductance। any inductive circuit का time constant क्या है? L by R, L by R, L by R। वो बोल रहा है उसका वैल्यू 2 है, टाइम कांस्टेंट इज 2, एंड इंडक्टेंस कितना दिया उसने? 15 हेनरी दिया है। तो रेसिस्टेंस कितना वो पूछ रहा है, ठीक है? सो R इज इक्वल टू L बाई 2, L is 15 divided by 2, that is equal to 7.5 ohms. Option is A for apple, 7.5 ohms it is. Option is A, 7.5 ohms, right? Yes. Next, calculate the time taken by series RL circuit having inductance of 0.6 Henry and resistance of 30 ohms to reach to steady state value. Good question, very good question. First of all, let's write the current formula of RL circuit. Current I of t is equal to, yes, some V by R into 1 minus e power minus R by L into t. So final current I of infinity आपको आएगा V by R। तो see RL or RC circuit takes 5 time constants, 5 time constants to reach steady state. To reach steady state, it is going to take how many time constants? It is going to take 5 time constants, right? Then time taken to reach to steady state is equal to 5 tau approximately. Exactly, it will take infinite amount of time. So tau कौन सा सर्क्यूट है? ये RL सर्क्यूट है, that is equal to 5 into L by R. L कितना? 0.6, R कितना? 30, so 5 6 it is, that is equal to 0.1 seconds, 0.1 seconds. Option is C for Chennai, 0.1 seconds. Option is C for Chennai, right? Next question. See, ये सुपरपोजिशन थ्योरम के बारे में है। थ्योरम्स वेरी इंपॉर्टेंट है, अगर दिया तो देखिए एक पेपर में कोई क्वेश्चन नहीं है थ्योरम का, एक पेपर में 3-4 क्वेश्चन है थ्योरम से। देयर आर 3 to 4 क्वेश्चंस related to theorems. That's why one must be good at theorems. Every topic, see what are the topics that are there for HPCL officer preparation. So all topics you must prepare very well. Superposition theorem is valid for which of the following circuit elements? See, I'll write here superposition theorem, Thevenin's theorem, Norton's theorem, maximum power transfer theorem. Okay, all these theorems are applicable for linear circuits only. Applicable for linear circuits. All these are applicable for linear circuits only. Linear circuits only. For non-linear, it is not applicable. For passive elements, it is applicable. Linear bilateral elements applicable. Resistive elements, it is applicable. He is asking superposition theorem is valid for B, C, but most related option is linear lateral bilateral elements. Linear bilateral elements. Linear and bilateral. See the statements I'll tell you. In any linear active bilateral network, the statement is in any linear active bilateral network. Okay, if you find the combination of these words, If you find the combination of these words, yes, that will be the answer. That will be the answer. Actually, you should, for passive elements also it is applicable. For see, circuit definitely will contain some passive elements, right? But most related option is option C, right? When a source is delivering maximum power to the load, the efficiency is 50% only. Is what is the condition for maximum power transfer? Condition for, yes, condition for maximum power transfer is R load is equal to Rs. Yes, this is a circuit. Resistance and load. Yes, this is V plus minus. This is Rs. This is RL. RL must be equal to Rs. Now, this is the load. What is the power that is delivered to the load? Power delivered to the load is equal to, yes, I square into R. V by Rs plus RL. Rs plus Rs. I square into R. How much it is? How much it is? Rs. This is delivered. Power supplied is how much? Power supplied is equal to, here you have to find, yeah, I square into Rs plus Rs. Rs plus RL actually. This is power supplied. Yeah. Power delivered, let's calculate clearly first. To the load is equal to V square by 4Rs into Rs. Rs gone. So V square by 4. V square by 4. Power supplied is equal to, how much is I? V by Rs plus Rs into Rs plus RL. Rs plus RL. How much it is? Yes, sir. I square into Rs plus RL, right? So Rs plus RL. Here, any mistake we committed? Yeah, PS is equal to, no, V square by 1 times Rs cancel, 1 time Rs plus RL is left here. Therefore, here you're going to left with 2. Now, power efficiency is equal to what? Power delivered V square by 4 by power supplied V square by 2 into 100. If you do, you're going to get 50% as the answer. Answer is 50%. Yes, option is, sorry, not D. It is A. Option is A. Option is what? A. Right? Next question. A voltage source having an internal impedance of 8 plus J6 ohms, okay, supplies power to a resistive load, 8 plus J6 ohms. Power supplies to a resistive load. What should be the load resistance for maximum power to be transferred? See, load resistance is equal to magnitude of the source impedance, that is equal to root of 8 square plus 6 square, root of 64 plus 36, root 100, that is equal to 10 ohms. Option is what? Option is C, 10 ohms. Option is what? Option C, that is equal to what? 10 ohms, please. Right? All questions are easy questions, but there is a small logic. Sometimes if you miss the logic, yes, please catch the logic. Next, अभी हमने डिस्कस किया है मैक्सिमम पावर ट्रांसफर थ्योरम के बारे में. ये क्वेश्चन आप करके, यस अंकित शर्मा, ये क्वेश्चन आप करके चैट बॉक्स में डाल देना आंसर. यस, आई एम वेटिंग फॉर योर आंसर. Yes. Yes. See, I'm waiting. Okay, Ankit Sharma saying, Shanti Vinnu, someone. Option is B. Yeah, it's a very simple question. Maximum power. What is P max? V square by, see, whenever RL is equal to RTH. That's all. 10 square V square by R. 10 plus 10. That's all. 100 divided by 20. That is equal to 5 watts. Option is, okay. See, That is the total power supplied. So he's asking power transfer to the load. Yes, power transfer to the load is asking. Sorry, I committed a mistake. So V by R is the current. 10 divided by R is 10 plus 10. I square into R. What is the resistance? 10. What is the resistance? 10. So I square into R, P max to the load. To the load. Okay. So that is 100 divided by 20 square. 20 into 20 into 10. So 0, 0 gone. Yes. Then you solve it. 100 divided by 40, that is equal to 2.5 watts. Answer is 2.5 watts. Option is B. B for Bombay. Option is B. B for Bombay. Right? Next question. The theorem which states that in any linear, non-linear, linear and non-linear, only theorem which is applicable. See, only theorem which is applicable for non-linear networks also is the only theorem which is applicable for nonlinear networks also is Telegan's theorem. Telegan's theorem. What this Telegan's theorem says is power supplied is equal to power absorbed. Yes, power supplied is equal to power absorbed. This is what Telegan's theorem says. The summation of instantaneous powers is equal to 0 is called as Telegan's theorem. See, if you see nonlinear, your hand should go to Telegan's theorem. That's all. That is only the theorem which is applicable for nonlinear. And Telegan's theorem is applicable for any circuit. It may be time variant or invariant, whatever it is. Telegan's theorem is applicable for every circuit. Next, for the circuit shown below, what is the values of Thevenin's equivalent voltage across the terminals AB? He's asking us to find Thevenin's equivalent voltage. So here already these two terminals are open. He's asking about ETH. That is open circuit voltage anyhow. No current will flow in this one. So these two are in series. 4 ohms and 6 ohms both are in series. This is 50 volts. 50 divided by 10. This current is 5 amperes. Yeah. How I got? See, this is no current. Why open circuit here? Open circuit, no current, 0 volts. Now the total current that is coming is flowing through this. 4 ohms and 6 ohms both are carrying same current. That both are in series. Series means resistance can be added. 4 plus 6 is 10. Therefore, current I is equal to 50 divided by 10. That is 5 amperes. Then this voltage. Now I am applying the KVL for this one. 5 amperes. 6 into 5 is 30. Yes, minus 30 plus 0 plus ETH is equal to 0. So from this one, ETH is equal to 30 volts. ETH is equal to 30 volts. Option is B. Option is B. Good, ma. Good. Right. Next question. Determine the value of source resistance. Okay, in ohms for transmitting maximum power from source to the load when the load impedance is 10 minus J2. Yes, is saying source resistance is asking. Source is having some resistance and load is having some reactance like this. Okay, this is R, this is minus J XC. Okay, R is equal to 10, this is equal to minus J2. Okay, now he is asking for maximum power transfer from here to here. For maximum power transfer from here to here, first of all, resistance cannot be negative. Resistance cannot be negative. Yes, and for maximum power transfer, if the source resistance is variable, I give a note point. Note for maximum power transfer, if the source is variable, yes, the resistance of source is as small as possible. Look at in the given options, the smallest value is option A. In the given options, the smallest option is option A. Right? Yes or not? Yes. Then determine the value of load resistance. Okay, for a circuit when the maximum power transferred from the source of 50 volts to the load is 25 watts. Determine the value of load resistance. Yes. See, what is the maximum power transfer formula? V square by 4 RTH is the value of the maximum power that is delivered to the load during maximum power transfer. During maximum power transfer, that is the value of maximum power that is transferred to the load, right? Yes or not? V square given 50 square, 50 into 50 divided by 4 times of RTH, don't know, that is equal to how much it is, 25. 25, it is 2 times 2, 2 times gone. So RTH is equal to 50 divided by 2 is 25 ohms. RTH is 25 ohms. Option is D. Option is D. See, that is a simple question, ma. I thought you'll give the answer before I complete. I thought you'll give the answer before I proceed, right? Option is D. Next, so there is a two-port network. See, this much depth not required. This much depth not required. We leave it. Otherwise, you can try. You can try. Yes. Then the input admittance not required. That much depth not required. Yes. Because that involves some 4-5 steps. That involves some 4-5 steps. That much time is not there in the HPCL examination. That much time is not going there in the HPCL examination. Simple questions. Maximum 1 or 2 steps of answering the questions they will give. Right? Answer this question, please, ma. Yes. The question is ABCD parameters of a two-port networks relates the following. Relates the following means two-port network. See, if you take any network, yes, this is a two-port network. This is a two-port network. Input, yes, voltage V1, current of I1, or first port 1. This is port 2, voltage V2, current I2, current of I2, two-port network, right? So it is going to relate V1, V2, I1, I2. These things it is going to relate. So all 4 options are having there. So V1, V2 with I1, I2, no. See, we have that also. V1, V2 with I1, I2 is Y parameters. What is that? Okay, he's asking specially about ABCD parameters. Yes, ABCD parameters. So ABCD means input. See, V1, I1 we know, and V2, I2 we want. Or see, these are known. These are known. These are unknown. We have to find V1, I1. So that is what ABCD parameters. ABCD parameters are transmission parameters. V1, I1 with V2, I2. V1, I1 with V2, I2. So these are Y parameters. Okay, these are something like uh, input current. See, suppose if I take this one as known, input current is known, output voltage is known, H parameters. This is H parameters. H parameters, right? Yeah. Try this next question, please. Good question. Try it, please. All of you, try it and let me know the answer. The Z matrix of two-port network is given by impedance matrix. Z is given. What is that? 0 0.9, 0 0.2, 0 0.2, 0 0.6, right? Now he's asking Y matrix. Matrix Y is Z whole inverse. Y22 is asking. Y22 means this last element. This is Z22. So what is a matrix inverse? 1 by AD minus BC. 0.9 into 0.6 minus 0.2 into 0.2 minus 0.2 into 0.2. The last element only. I'm not going to find all the elements. These two can be exchanged. These two can be minus, sign changed. Sign should be changed to minus than what it is existing. So this will become 0.9. So answer is 0.9 by 0.9 into 0.6. Okay, 0.54, I guess, minus 0.2 into 0.2, 4 into 10 to the power of minus 2, that is 0.04. Now 0.9 by 0.5, answer is 9 by 5. So 9 by 5, please, it is not 8. 5 ones, 5 eighths, 5 ones, 5 eighths more, 1.8 more. Option is C, C for Chennai. Observe it, option is C, C for Chennai. Right. Next. For a two-port reciprocal network, he's saying the network is reciprocal. Reciprocal means it's a passive network. All passive networks are reciprocal. The condition in terms of ABCD parameters is AD minus BC is equal to 1. A is 4, D is 5. AD minus BC, yes, is equal to 1, it should be. Now what is saying? A is equal to 4, B is equal to 7, C is equal to 5. D did not given. D did not given. Sorry. AD. A is 4, D did not given. AD minus BC, yes, BC 35 is equal to 1. 4D is equal to 36. D is equal to 9. Option is B, B for Bombay. Yes. You see, option is B, B for Bombay. Yes, Miss Shanti Vinnu. Yes, option is B, B for Bombay, right? So this much big circuit not required, this much big circuit not required, leave it. Now answer this question, please. I'll wait for 1 minute. As it is a theory question, I'll wait for 1 minute. Yes, a simple question it is. Right? Yes. Let me solve what he's asking. Which of the following expression shows correct expression for Y parameter? मैंने अभी बोला है Y parameter means current is expressed in terms of voltages. I1 is equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. Means I1 comma I2 are functions of V1 comma V2. V1 comma V2. I1 comma I2 are functions of V1 comma V2. Option is B, B for Bombay. Right? Yes. Next question, please. For a two-port reciprocal network, yeah, D, repeated question. We solved it previously. Now he's asking the value of H22 for the network shown in figure is. He's asking for H22. What are the H parameters? H parameters are, see, output, input, see, input current is known, comma, output voltage is known. These two are known. Then unknown are V1. V1 is equal to H11 I1, H12 V2. See, next one is I2. I2 is equal to H21 I1 plus H22 V2. Now, what is H22? H22 is equal to I2 by V2 when I1 is equal to 0 means when this I1 is equal to 0, this current is 0 and this current is 0 amperes. Let's make it. Now whatever the I2 is going, which is equal to 300 I1, whatever I2 is going, that is going this way to the ground, right? That is going this way to the ground. So uh, it is V2, voltage V2 is needed. Voltage V2 is needed. It is 0. It is 0. The reason is I2 is there, but what is V2? See, this is current source whose voltage is unknown for us. Whose voltage is unknown. Let's find V2. Minus V2 plus 0 plus V1 is equal to 0. So V2 is equal to V1 we got, but we did not got any value. We did not got any value. Or let's write the equation for I2. Let's write the equation for I2. At this node, I1 is incoming. See, I1 is incoming plus I2 is also incoming, that is equal to 0. I1 plus I2 is equal to 0. So from this one, I2 is equal to minus of I1. I2 is equal to minus of I1, right? That is equation 1. So I1 is equal to V1 by 50. V1 by 50. That's okay. Now, right. I1 is equal to V1 by 50, but I want I2 in terms of I1 and V2. I1 and V2, right? Something is missing in the question. Something is missing. The reason is if I write V2 equation minus V2, right? This voltage is unknown for me. This is the current source. That is the current source whose voltage is unknown. I am unable to write the KVL there. Leave it. There is something missing. This much big question not required. Next question. For H parameter model, the condition for symmetry is H. See, condition for symmetry in terms of Z parameters, Z12 is equal to Z21. In terms of Y parameters, Y12 is equal to Y21. Right? In terms of ABCD parameters, AD minus BC is equal to 1. In terms of H parameters, I am asking. Answer, please. Answer, please. I am giving 1 minute of time. I am giving 1 minute of time. Yes, answer, please. Yes, my question is condition for symmetry. Condition for symmetry. 30 more seconds I'll wait. See, 1 minute is the time I am giving. In that 30 seconds already done. 30 more seconds. Yes, answer is yes. Delta H. Delta H must be equal to, means delta H means determinant. What is determinant? H11, H12, H21, H22. Right? It's a determinant you find. It's determinant. How? What is the determinant? H11. Yeah, this H11 into H22 minus H12 into H21 must be equal to 1. That is a condition for symmetry. That is the condition for symmetry, right? Yes or not? Yes. See, we solved almost some 55 to 60 questions. 55 to 60 questions. YourPedia started a dedicated module for HPCL officer examination, CBT preparation, and we are the I can say leaders in CBT preparation as well in GD, GT, and personal interview and technical interview programs. Okay, so HPCL is a simple examination, but with the right direction. If you start studying by taking some other competitive examination, people may claim like, sir, I prepared for GATE. No, GATE preparation is completely different from HPCL preparation. For HPCL, you have to go in the right direction. That is very, very important. At YourPedia, our module goes exactly in the direction of HPCL, right? So you can join our module, which is already running. Okay, you can join our module. Yes, if you have any queries, you can call to the number that is mentioned in the description box, right? Yes, all the best. Thank you.